Hello everyone, welcome to my YouTube channel. My name is Lilian Mutemi. I am a TVET trainer by profession. And today I want us to learn about building material science. This is a common unit of competency in building technician level 6. And as we begin, I want us to begin with the first topic, which is introduction to building materials. And first of all, I want us to go through the specific objectives that a trainee must meet at the end of this topic. So the first objective is that a trainee should be able to describe the general properties of construction stroke building materials. Objective number 2 is that a trainee should be able to classify the common materials that are used in construction of a building. And then number 3, the trainee should be able to differentiate between mineral and organic materials. As you can see, this is a picture of some of the construction materials that are used in the construction industry. You can see cement, you can see aggregates, you can see concrete, you can see a brick, you can also see a steel reinforcement. So these are just examples of a few materials that are used in the construction industry. We shall be seeing more about them later on in the unit. So going to the first subtopic, which meets our first objective, is the general properties of construction materials. These general properties give us some of the factors that we should consider when selecting a material for a particular building construction, which will be will be affected by the climate of the area and also the needs of the client, among others. So as we look at these general properties, we will be getting also the factors to consider what will make us select a particular material for a particular structure. The first general property is the thermal regulation, and we can begin by defining what thermal regulation is. Thermal regulation refers to the ability of a material or system to control and maintain a desired temperature within a space. It involves managing heat transfer to keep the interior of a building or an object at a comfortable and stable temperature, regardless of the external conditions. Why is thermal regulation important? How is it important in as a general property? Yes, we can see effective thermal regulation is crucial for energy efficiency in buildings and for maintaining comfortable indoor environment. Insulation materials, windows, and HVAC systems are commonly used for thermal regulation. So basically, when we are talking about thermal regulation, we can look at it in a different aspect. You'll find that there are some of the construction industries that are, construction materials that absorb heat. An example is a building stone. It is capable of absorbing heat probably during the day, and then at night, that is during the day, it will help to regulate the heat inside the building, because when it absorbs it, it is retained. So inside the house, it will be cold, or rather the temperature will be regulated, it won't be too hot. And then also now at night, the heat that was absorbed will help to regulate the internal temperatures. Then you also have some other materials that insulate a building from high temperatures, especially the materials that are used in construction of a roof. Then moving forward, we'll also look at also the ability of a material to conduct heat, that is the thermal conductivity. Then we also look at the thermal mass. Thermal mass is the ability of a material to absorb heat, store heat, and stabilizing the indoor temperatures. You have talked about it. We also have materials that reflect. They reflect heat. Example are the roofing materials, and reducing the heat absorption and lowering the cooling cost. Moving forward to property, general property number 2 is the strength. It is the strength. If it were to define the strength of a material, we will see that it is a capacity of a material to withstand applied forces without deformation or failure. It measures the material's ability to resist stresses, including tension, compression, shear, and bending. So when we are looking at strength, we are looking at this aspect of compressive strength, whereby a material is it measures the material's ability to withstand pressure, or rather axial loads. Then when we look at the tensile strength, it measures the material's ability to resist tension forces such as stretching or pulling. Then you could also be looking at shear strength, which measures a material's ability to resist or to withstand forces that act parallel to its surface. We also look at the flexural strength, which measures the ability of a material to resist bending or flexing. So then, how is strength of a material important? Strength is a fundamental property in engineering and construction. It ensures the structural integrity and safety of buildings and infrastructure. Materials with high strength are used in load-bearing components like beam, columns, and foundation. I will give an example with concrete. Concrete, which is not yet reinforced, has high compressive strength, while when it is reinforced, then the steel that is used to reinforce concrete has high tensile strength. So they complement one another, and they provide great strength in a structure, because when you are looking at the foundations, at the columns, at the slab, at the beam, the reinforced concrete is used to construct them, and hence when you're building a story building that requires the loads to be transferred from the highest story to the foundation, they're usually transferred through the beams and column, then to the foundation. Hence, the reinforced concrete is important to help to provide high strength that will be used in those load-bearing components. Moving forward to the third general property, we have sound regulation. Sound regulation, which is also known as acoustic regulation. How do we define sound regulation? Sound regulation refers to the control of sound transmission or absorption within a space. It involves using materials and design techniques to minimize the transmission of unwanted It involves using materials and design techniques to minimize the transmission of unwanted noise and to enhance sound quality within a specific area. Sound regulation, we are looking at it in this aspect, including and not limited to sound absorption. You'll find that we have materials that are porous or have fibrous structures like acoustic panels, ceiling tiles, and those ones are used to absorb sound, hence reducing echo. Especially in probably in structures such as concert halls. And we also have sound insulation, whereby materials with high density and mass, like concrete or also gypsum board, can block sound transmission. We also have sound reflectance, whereby we have some materials that can absorb sound. Hence, they are useful for creating specific acoustic environment. So, why is sound regulation important? Why is it a property or a factor that will be considered when selecting a material for a particular structure? Effective sound regulation is important for creating comfortable and noise-controlled environment, such as in residential buildings, offices, and concert halls. Sound-absorbing materials, wall insulation, and acoustic design principles are used for sound regulation. Moving forward to the property number 4 is fire resistance. So what is fire resistance? Fire resistance is the ability of a material or assembly to withstand exposure to fire or high temperatures without losing its structural integrity or contributing significantly to the spread of fire. It is typically measured in terms of fire ratings or the resistance to flame, heat, and smoke. So when we talk of fire rating, we have materials that can be rated for the ability to resist fire and to prevent its spread. The ratings are usually commonly done maybe in 1 hour, 2 hour rating, 3 hours, etc. Then you also have the other aspect of flammability. Here we have materials that can be classified as non-combustible, fire resistant, or combustible based on their reaction to fire. And then looking at smoke and toxic gas emission, we also have materials that might emit smoke or toxic gases when exposed to fire, impacting occupant safety. So depending on such factors and properties, then we can rate the fire resistance of a particular material. Then moving forward, why is fire resistance important? Fire resistance is a critical safety requirement in buildings to protect occupants and limit property damage during fires. Materials with fire resistance properties, such as fire-rated doors, fire-resistant coatings, and fire-proof insulation, are used to enhance fire safety. Moving forward to the last general property, which is durability. How can we define durability? Well, durability refers to the ability of a material or product to withstand wear, aging, and deterioration over time while maintaining its intended function and appearance. It involves resistance to factors like moisture, UV radiation, temperature fluctuation, and mechanical stress. So when you're looking at the durability of a material, we look at it in several aspects. One of them, as you have mentioned, is fire resistance. Here we have materials which are supposed to withstand exposure to weather elements like rain, wind, and UV radiation. Actually, they should be made, or rather they should have that property in a way that we can say they must be able to withstand exposure to weather elements like rain, wind, and UV radiation. Then the other aspect is corrosion resistance, whereby we have certain materials like stainless steel or corrosion resistant coatings that are used specifically in corrosive environments. Then we also look at the aspect of wear and abrasion resistance. Here we are looking at the materials that are used in high traffic areas like flooring and countertops, which need to resist wear and abrasion. You also look at the aspect of chemical resistance. Here, when we are selecting materials for places such as in an industrial setting, they will require resistance to chemicals and acids. Then we also have the aspect of decay resistance, whereby materials used outdoor or in damp environment need to resist decay, such as rot in wood or even rust in metals. Why then is durability important? Durability is essential for the long-term performance and maintenance of structures. Therefore, durable materials, coatings, and construction techniques are used to ensure that buildings and infrastructure remain functional and aesthetically pleasing for extended periods. In summary, I would say that the selection of construction materials will depend on the specific requirements of a project, including and not limited to the structural design, climatic conditions, fire safety regulations, acoustic consideration, and also the budget constraints. Therefore, the building professionals should carefully choose materials with the appropriate combination of properties to ensure the safety, comfort, and longevity of the constructed building. Moving forward to the next subtopic, she mentioned in the objective number 2 is the classification of building construction materials. So we are going to look at the broad classification of these construction materials. So broadly, construction materials can be classified into several categories based on their composition and characteristics. The first classification, we are going to classify construction materials as engineering materials. As engineering materials, we can define them as materials that are specifically designed and selected for their mechanical, thermal, electrical, and chemical properties to meet the requirements of a particular engineering application. Generally, examples of such include steel, concrete, timber, plastics, and they might, or rather they will be chosen for their structural, thermal, electrical properties depending on where it will be applied. So that is a picture of a sample engineering materials. You can see timber, you can see aggregates, you can see steel, you can see some nails, you can see some clay products here, among others. So we can further now list or rather outline some types of engineering materials whereby they can further be classified further as either civil or structural engineering material, electrical. We also have mechanical, because in any building structure you must find the structural works, you will find electrical works, you will find mechanical works. And so when we are subclassifying these materials as in those several types of engineering materials, we are now classifying them based on the specific work that they will be doing. So when we classify them as civil or structural engineering materials, we'll see some common types of such. One of the types of civil or structural engineering materials is concrete. And concrete mostly is used in the foundations, columns, beams, and slab, and it provides strength and stability to the structure. You can also see the steel as a common type of a civil engineering material. It is commonly used in structural framework such as steel beams and columns. It offers high tensile strength and flexibility. We also have another example, which is wood. And wood is used for structural framing, such as in wooden beams and trusses. It is often used in residential construction. Then you also have masonry. The masonry materials will include materials such as brick, concrete blocks, and stone. These ones are used for load-bearing walls and partitions. Going to the second type of engineering material, we go to the electrical engineering materials, which comprise of both conductors of electricity and non-conductors of electricity. So here we have some types of electrical engineering materials, beginning with the conductors. Here we have copper and aluminium wiring, which is used for electrical wiring and as a conductor of electricity. We also have electrical boxes and panels. These ones include the junction boxes, circuit breaker panels, and electrical enclosure. Then this is a non-conductor of electricity. We go to the insulation material, which is also a non-conductor of electricity. These are materials that are used for insulating electrical wires and cables. Then we also have another example of a non-conductor, which is conduits and pipes. This is used to protect and route electrical wiring within the building. We also have some more other examples, but for now we can just outline a few, but you can also find out about more of the types on your own. Then moving to the mechanical engineering material. Here we have materials that are mostly used in the pipe works, water distribution system, and they include pipes and fittings. These are materials like steel, copper, and PVC for plumbing, and also HVAC systems for heating, ventilation, and air conditioning. We also have ductwork. We have materials for HVAC duct, such as the sheet metal, fiberglass, and flexible ducting. We also have materials for pumps and motors. These are mechanical components used in heating, cooling, and water distribution system. Then we have fasteners and hardware. Here we are talking of materials such as nut, bolt, screw, and other mechanical fasteners used in construction. Moving forward to the other major classification of construction materials, we can classify construction materials as metals and non-metals. Materials are subdivided into metallic and non-metallic, and the metallic materials are further subdivided into ferrous and non-ferrous materials. We know that ferrous are the metals that consist of iron, rather made of iron, while non-ferrous don't have iron. So then when we talk of metallic materials, they are characterized by their high electrical conductivity, malleability, which is the ability for them to be made into a sheet. Then you also have ductility and strength. They are widely used in construction for their structural and functional properties. Examples, we have steel, aluminium, copper, and iron. Moving forward to non-metals. Non-metals include materials that lack the typical properties of metals. They are mostly used for insulation, cladding, or other non-structural purposes. Here we have examples such as plastic, rubber, and fiberglass. Moving forward to the other major classification of construction materials, they can be classified as metal alloys, ceramics, and organic materials. So what are alloys? Metal alloys. Alloys are materials formed by mixing two or more elements, often including at least one metal. Alloys combine the properties of their constituent element to create materials with desirable characteristics. For example, we have steel, which is an alloy of iron and carbon. It is one of the most common construction alloy. We also have other examples such as stainless steel, brass, and bronze used for specific applications. Moving forward to ceramics. What are they? What are ceramics? Ceramics are inorganic and non-metallic materials that are typically characterized by the hardness, brittleness, and resistance to high temperatures. They are used in construction for their durability and heat resistant properties. We have examples such as clay bricks, ceramic tiles, refractory materials used in kilns and furnaces. So those are some of the examples for ceramics. We go to the organic materials. Organic materials are derived from living organisms or contain carbon-based compounds. They are used in construction for various purposes, including insulation, finishes, and aesthetic. We have several examples, including wood, bamboo, natural fibers, and organic insulation materials like fiberglass and cellulose. So basically, in summary, construction materials can be classified in various ways, basing on their properties, composition, and also their intended use. So we can move to the last objective of our topic number 1. The third objective was telling the difference between mineral and organic materials. Mineral and organic materials are usually two broad categories of construction materials used in various applications. They have distinct characteristics, properties, and uses in construction and other industries. So those are just two broad categories of the construction materials. So why would you call a material a mineral material? What is a mineral material? Well, mineral materials are naturally occurring in organic substances found in the earth crust. They are typically extracted, processed, and used in various forms for construction purposes. They have some distinct characteristics which are relate to the characteristics of the mineral in them, like a material has been sourced from a mineral. So depending on the parent source, the kind of mineral that was in the parent source, this material will have similar characteristics. So basically, some of the characteristics of minerals or of mineral materials include hardness. We also have durability. We have heat resistance. We also have variety. whereby when you talk of variety, we are talking of a wide range, like they are in a wide range, including maybe stones such as granite and marble. You have aggregates, which might be in fine aggregates like sand, or coarse aggregate like gravel. You also have clays and other minerals that are used in cement and concrete production. Then moving forward to the common uses. What are the common uses of these mineral materials? One of the common use is that they are extensively used in construction for foundation, walls, flooring, roofing, and decorative purposes. In the foundation, we have the concrete that is used in the foundation. We also have stone, an example of a mineral material that is used in foundation walling. We have masonry walling, whereby we are using a building stone or a brick. Flooring, we have ceramic tiles. Roofing, we have the roofing tiles. Decorative purpose, we have some decorative stones such as marble and granite that are used as a stone facing to decorate mostly the exterior of a building. We also have use in infrastructure. In infrastructure, we have aggregates like gravel and crushed stone that are vital for road construction and concrete production. When you're talking of infrastructure, we are talking of things like roads, dams. So there we have the gravel and the aggregates that will be used in construction of such structures which are not building, rather which is not a building structure. It is an infrastructure. Then moving forward to the other common use is the manufacture. Materials are used in production of glass. Glass, we have materials such as limestone, soda ash. We have ceramics that are made from clay. We have cement, which is made from limestone, and other products that are used in construction that are produced from minerals. Then moving to the organic, hoping we have understood what a mineral material is. Now we can look at the organic material. What are organic materials? How do we define them in a way that they are different from, rather to differentiate them from a mineral material? Organic materials are materials which are derived from living organisms, or they contain carbon-based compounds. When I say carbon-based compounds, we are basically saying they are either gotten from plants or they are gotten from animals. They are versatile and have various applications in construction and other industries. Characteristics of these organic materials, we are talking of a characteristic such as sustainability. When we talk of sustainability, it is the ability of organic material to be renewable and also environmentally friendly. An example is wood. Wood is very much renewable. It can be used, without depleting, and it does not pollute the environment. We also look at the insulating properties. Organic materials have excellent insulating properties, making them suitable for temperature and sound regulation. You can also look at another characteristic, versatility. When we talk of versatility, we mean that there are a wide range of application. It can be used, or it can be applied, be used for different things. For example, when you look at a material such as a wood can be used in framing of doors and windows. It can be used also to make the door and also to make the window. It can be used for formwork. It can be used for walling. It can be used for flooring. It can be used for roof, or rather making the truss for a roof. It can be used for finishes, the interior finishes, there is cabinetry. It can be used even to make the other furnishes such as sofa. So it has a wide range of application in the construction industry. So basically, in other words, we can say that organic materials can be used in structural and non-structural application, including framing, finishes, and insulation. Let's look at the common uses of organic materials. One, we have wood. Wood is a versatile organic material used in construction for framing, flooring, cabinetry, and decorative finishes. Use of bamboo. Bamboo is a rapidly renewable material used for flooring, wall panels, and structural components. Insulation. Organic materials like fiberglass, cellulose are commonly used for thermal and sound insulation. Finishes. Organic paints, stains, and varnishes are used for decorative finishes in construction. So then lastly, we can now compare the mineral materials and organic materials based on their sources, renewability, strength, insulation, and also environmental impact. So when you look at the source of these two materials, two broad categories of materials, we see that mineral materials are derived from geological processes. That is through the formation of rocks, then they are quarried, produced to make the mineral material. While organic materials come from living organisms and carbon-based compounds. When we look at the comparison in terms of renewability, you find that organic materials such as wood and bamboo are often renewable. Hence, they are considered to be more sustainable compared to mineral materials. Then strength is the other comparison. You find that the mineral materials tend to have higher compressive strength, making them suitable for load-bearing application, while organic materials like wood have good tensile strength. Moving forward to the other comparison, which is insulation. You find that organic materials are mostly preferred for insulation due to their natural insulating properties compared to the mineral material. And lastly, environmental impact. Organic materials have a lower carbon footprint compared to some mineral materials, depending on their sourcing and processing. Hence, you find that the organic materials are more environmentally friendly compared to the mineral materials. So as we summarize our topic, our subtopic, we can see that in construction, the choice between mineral and organic material will depend on factors such as structural requirements, sustainability goals, aesthetic preferences, and budget constraints. A combination of both types of materials is often used to achieve the desired performance and appearance in building project. So basically that is all in the introduction of the building construction materials. So next, or rather in the next topics, we'll be looking at individual material. Where we come and look for a stone, we look at the origin of the stone, how are they classified, what are the properties of a good building stone, what are the main production methods, what are the various defects and how they can be corrected, testing, so we'll be looking at specific building construction materials. Then we look at its properties and application in the construction industry. So I hope you have learned something in our today's session. My hope is that you will get to understand this unit more and more, and even as you will be now applying it practically, that you shall be able to, or you shall have the knowledge that is required to apply this unit practically. Thank you. Have a nice time. Bye.